Off the coast of Vancouver Island, scientists have just captured something no research team has ever documented this clearly before: a subduction zone caught in the literal act of dying. Using sound waves to image the seafloor along the northern Cascadia Subduction Zone, researchers discovered that a slab of ocean floor has dropped roughly 5 kilometers along a fault that is, in their own words, close to breaking clean through. This is not a small, incremental correction to an existing model. It is the clearest direct picture geologists have ever obtained of exactly how a subduction zone, the same type of fault system responsible for the largest earthquakes on the planet, actually shuts down. Lead researcher Brandon Schuck, who worked on the study while a postdoctoral researcher at Columbia's, described the discovery in terms that make the significance immediately clear, saying, "This is the first time scientists have a clear picture of a subduction zone caught in the act of dying, breaking apart piece by piece rather than shutting down all at once. This is the story of exactly what researchers found beneath Vancouver Island, why it solves a genuine geological mystery scientists have puzzled over for decades, and what it does and does not mean for the earthquake risk facing the Pacific Northwest." No exaggeration, just what the journal Science Advances, Lamont Doherty Earth Observatory, and the researchers behind this exact study are actually reporting. Drop a comment and tell me if you live anywhere across the Pacific Northwest and how closely you follow Cascadia earthquake. Research, because this region has had an unusually active year for exactly this kind of discovery. I read every one of these. If you want grounded science coverage instead of recycled panic, subscribe. It is free, and a like helps this reach people who live along this exact fault system. Let us go for 5,000 likes on this one. Now let us get into it. To understand why this discovery matters, you first need to understand what a subduction zone actually is, and why geologists have struggled for so long to understand how one eventually stops. A subduction zone forms wherever one tectonic plate dives beneath another, and these systems are responsible for the planet's largest earthquakes and its most explosive volcanoes, slowly recycling old ocean crust back down into the mantle over millions of years. Off the coast of Washington, Oregon, and British Columbia, the Cascadia Subduction Zone is exactly this kind of system, where the Juan de Fuca and Explorer plates slide beneath North America. Geologists have long understood that subduction cannot simply continue forever, since a system that never stopped would eventually erase entire oceans and stack continents on top of one another, but they have never had a clear, direct picture of exactly how the process of shutting down actually unfolds in real time. That gap in understanding is precisely what this new research fills, and it matters well beyond pure scientific curiosity, since the specific way a subduction zone breaks apart can directly shape how future earthquakes along that same system behave, whether they stay contained to a single segment or spread across a much larger stretch of fault at once. The images behind this discovery came from the 2021 Cascadia Seismic Imaging Experiment, known as CASI-21, conducted aboard the research vessel Marcus G. Langseth, and led by Lamont Doherty scientist Suzanne Carbat, who later co-authored the new study with colleague Anne Beckel. To see beneath the seafloor, the research crew sent sound waves down into the ocean floor and recorded the returning echoes using a 15-kilometer-long streamer of underwater listening devices, a technique called seismic reflection imaging that functions essentially like an ultrasound of the Earth's subsurface. About 20 scientists across Lamont Doherty, Louisiana State University, Auburn University, the University of Texas at Austin, and several other institutions have spent time analyzing the resulting data set. What those images revealed were tears cutting directly through the descending Juan de Fuca Plate, including one massive break, roughly 75 kilometers long, where the slab is dropped by about 5 kilometers, a scale of structural detail. No prior survey of this fault system had ever captured this precisely. The earthquake record along that same fault gave researchers a second independent line of evidence supporting what the imaging showed. Along the 75-kilometer tear, some sections continue producing small earthquakes, while neighboring stretches have gone completely silent. Schuck explained that this silence is not simply a gap in the available data, but a genuine physical signal, since once a piece of the plate has fully broken away, it no longer grinds against its neighboring rock, and therefore stops generating earthquakes altogether. Where the earthquakes have stopped, that section has likely already separated and is drifting slowly away from the piece still being pulled underneath the continent, a genuinely striking way to visualize a process that normally unfolds far too slowly and far too deep underwater for anyone to observe directly. The main fault itself, where researchers measured the 5-kilometer drop, has not fully detached yet, with Schuck noting plainly that it is not 100% torn off, but it is close. Researchers are calling this overall pattern episodic or piecewise termination, meaning the plate does not break in one single catastrophic event, but instead separates piece by piece across a series of episodes, each one unfolding over several million years, gradually reducing the pull that keeps the remaining plate subducting, similar to how a train loses momentum once individual cars get cut loose from the back. This discovery does something else that is genuinely significant beyond simply describing what is happening off Vancouver Island right now, because it solves a puzzle geologists have carried for decades. Off Baja California, researchers have long identified scattered fossil microplates, the leftover remains of the Farallon Plate, a much larger plate that subducted beneath North America before eventually disappearing entirely. For years, scientists understood those fragments as evidence that the ancient subduction zone responsible for them had died, but without a live example to study directly. The actual mechanism that produced those scattered pieces remained genuinely unclear. Carbot explained that geologists have known for decades that subduction can stall when a buoyant section of oceanic plate reaches the boundary, but catching the actual breakup process in progress, rather than reconstructing it after the fact from ancient scattered evidence, is entirely new. Cascadia has effectively supplied the missing piece of that puzzle, demonstrating that subduction zones do not collapse all at once, but unravel step by step, leaving exactly the kind of microplates behind that researchers have been finding as fossils elsewhere along the Pacific coast for years. It is worth being precise here about what this discovery does and does not change regarding earthquake risk in the Pacific Northwest, because that distinction matters enormously for anyone living in the region. According to the researchers themselves, this finding does not alter how large an earthquake Cascadia could produce on any timescale relevant to people alive today. The subduction zone remains fully capable of producing very large earthquakes and tsunamis, a hazard that decades of prior independent research had already firmly established well before this study. What the new imaging adds is structural detail researchers simply did not have before, a considerably sharper picture of the specific faults and fractures running through the plate itself. Scientists are now actively studying two genuinely open questions building directly on this new data: whether a major rupture along Cascadia could potentially jump across one of these newly identified tiers, or whether the tiers might instead act as a natural barrier, blocking a rupture from spreading further along the fault than it otherwise would. Refining that picture is expected to meaningfully improve the models researchers use to assess seismic hazards across the entire region going forward. This discovery also arrives during a genuinely unusual stretch of Cascadia-focused research this year, worth understanding for context. Separate research published earlier in 2026 found that the Juan de Fuca Plate sits roughly 5 kilometers shallower beneath northern Oregon than previous hazard models assumed, a finding presented by USGS seismologist Aaron Worth that has its own separate implications for how strongly the ground could shake during a future megathrust earthquake. Other research teams this year have been studying how fluid trapped within different sections of the fault appears to build stress differently between Cascadia's northern and central portions, while still another study found evidence that Cascadia's megathrust in California's San Andreas Fault may be more connected than scientists previously believed. Taken together, none of these individual findings represents a single dramatic revision to the region's earthquake threat, but the sheer volume of active, ongoing research this year reflects just how much scientific attention this fault system continues to receive, precisely because of how directly it threatens the millions of people living across the Pacific Northwest. So what does all of this actually mean if you live anywhere across Washington, Oregon, or British Columbia? The practical lesson is not that this specific discovery increases your immediate earthquake risk, since researchers are explicit that it does not change the fundamental hazard picture on any human timescale. What it does mean is that the broader scientific case for continued Cascadia earthquake preparedness remains exactly as strong as it already was, reinforced by an increasingly detailed picture of exactly how this fault system behaves. Have an emergency kit with water, food, and medication ready at home. Know your household's earthquake and tsunami evacuation plan if you live near the coast. Secure heavy furniture that could fall during strong shaking, and make sure your phone has earthquake early warning alerts enabled, since Cascadia remains capable of producing the kind of magnitude 9 earthquake that made it one of the most studied fault systems in the world well before this particular discovery. None of that preparation depends on believing this specific finding has moved the timeline closer. It simply reflects the same honest reality Cascadia has represented for decades, a fault system capable of a genuinely historic earthquake that no current science can predict with any specific timing. The honest, grounded summary is this. Using detailed sonar imaging from a 2021 research expedition, scientists have captured the clearest direct evidence yet of how a subduction zone actually shuts down, documenting a 75-kilometer tear beneath Vancouver Island where a section of the Juan de Fuca Plate has dropped roughly 5 kilometers and sits close to fully breaking away. Published in Science Advances, the research shows this happens through a piecewise process rather than a single catastrophic event, And it directly explains scattered fossil microplates off Baja California that geologists have puzzled over for decades without ever having a live example to study. Researchers are explicit that this discovery does not change the fundamental earthquake and tsunami hazard Cascadia poses on any human timescale, though it is now feeding directly into ongoing research examining whether these newly identified tiers could influence how a future major rupture actually spreads along the fault. We are going to keep tracking research on this fault system the way we tracked it today, straight from science advances, Lamont Doherty Earth Observatory, and the researchers actually studying Cascadia, not recycled headlines. Subscribe so you do not miss it as scientists continue analyzing exactly how these tiers might shape future earthquake behavior, because this has clearly been one of the most active years for Cascadia research in recent memory. And leave that comment below. Tell me if discoveries like this one change how you think about the ground beneath the Pacific Northwest. Because watching a subduction zone caught mid-collapse is not something scientists have ever been able to document this clearly before. Because behind every one of these seismic images is a research vessel that spent weeks towing a 15-kilometer sensor line across open ocean back in 2021, a team of scientists who spent years afterward turning that raw data into an answer to a question geologists have carried for decades, and millions of people across the Pacific Northwest going about an ordinary day, entirely unaware that the fault system beneath their coastline is being watched more closely and understood more clearly than at almost any point in human history. 5,000 likes on this one. Let us go. See you in the next one.